Welcome back today. Today is Chapter 10, and Chapter 10 subject is depreciation. We introduced depreciation back in Chapter 3, which was the adjusting entry chapter, maybe your favorite chapter, everybody's favorite chapter. Well, we're back to depreciation, and I think it's worth taking a minute to refresh your memory on what is depreciation. You can see we've got the definition up here. The process of allocating the cost of a plant asset to expense in the accounting periods benefiting from its use. Well, let me elaborate on that. Let's say we buy $1 million machine this accounting period, and this machine is projected to last, let's just say 10 years. Well, it wouldn't make sense, or it wouldn't be very accurate if we recorded all of the $1 million as an expense in the period that we happen to purchase the machine. So what we do is we take the cost of the machine. We know it's an expense, but we take that cost of the machine and we spread the expense out over the periods that benefit from that machine, and that is called depreciation expense. We're required to do that because of the matching principle. Matching principle says that you must record the expenses in the period that you record the revenues. In other words, match your expenses with your revenues. Well, if this machine helps us produce revenues for each of the next 10 years, then each of those next 10 accounting periods need to share in the expense of the machine, the $1 million expense. So we spread it out over the life of the asset, and that is depreciation expense. Now, what you might be thinking about is, how do we decide to spread it out? Well, there are three methods that we're going to cover today in terms of spreading that cost out. The first method is called the straight line method. We're going to go through an example of the straight line. The second method is called the units of production method, and the third one is called the declining balance method. So let's take one at a time. Let's start with straight line, and let's do an example. We're going to go back to the Kidd Company and do an example here. We use the same example for each of the three methods. First off, straight line. All right, it says Kidd Company purchased a new machine costing $550,000 with a 5-year life and a $50,000 salvage value. We estimate that the machine will last 5 years. And then at the end of the 5 years, we estimate that it'll have about a $50,000 salvage value. Okay, straight line, very simple to calculate depreciation using straight line. There is the formula. You just take the cost minus the residual. Residual and salvage value are the same thing, a different terminology. Then you divide the cost minus the residual value divided by the life in years, and that equals the depreciation expense per year. So let's apply that to our numbers we have here. We take the cost of $550,000 minus the $50,000 salvage residual value. That leaves us with $500,000, and that $500,000 is called the depreciable cost of the asset. Divide that by 5 years, and that equals $100,000. So if we use the straight line to depreciate this asset, we're going to depreciate it at the rate of $100,000 per year for the next 5 years. If we use the machine for 6, 7, 8 years, well, we've already used up all the depreciation. We cannot continue to depreciate the asset beyond that $500,000. All right, so that's straight line. Pretty simple, right? Well, then you're going to like units of production, the next one. Let's use the same example. Same thing, we purchased a machine for $550,000, $50,000 salvage value. But now, instead of estimating that the machine is going to last 5 years, let's state the life in terms of some production method. It could be miles if it's a vehicle, it could be units produced, or in this example, we're estimating that this machine will last 21,740 hours. So the machine has to obviously have some type of an hour meter on it that tells us how long we use it. Let's just assume that we actually used the machine in the first year 3,500 hours, the second year 7,000 hours, the third year 6,500 hours, fourth year 3,000 hours, and the fifth year 4,000 hours. All right, we're going to use the same formula that we used in the straight line method. Take cost minus residual, 550,000 minus the 50,000 residual, and we divide by, again, you can see our 21,740 there. That is our life in hours, and that comes out to depreciation per hour. We're going to have to convert that to depreciation per year, but it comes out to 22.999. I'm okay with rounding that up to $23. I think we can ignore that 1/1000th of a penny there. $23 per hour. So we're going to depreciate at the rate of $23 per hour. Now, all we do is multiply the amount that we've used each year. So you can see in year one, we actually used the machine for 3,500 hours. Just simply multiply that times our depreciation per hour, and that gives us our depreciation of 80,500. Check my math. Going down here, year two, we estimated we'd use the machine 7,000 hours. So we take the 7,000 times 23, depreciation of 161,000 in the second year. You can see we did the same thing third year, 6,500 hours times the 6,500 usage that we actually used it. Year four, 3,000 times 23, and that takes us through year four. Okay, you see what we're doing. Now, one word of caution here. You can never depreciate an asset beyond that depreciable cost, in this case, the 500,000. If you add up all our hours up here, the 3,500 plus the 7,000 plus the 6,500 plus the 3,000 plus the 4,000, you will see that it adds up to more than the estimated life of 21,740. Well, we cannot depreciate the asset beyond the 21,740 hours. Actually, if you just add up these first 4 years of usage here, they add up to 20,000. We can only depreciate this for 21,740 hours. So what that tells me is in the last year, we can only depreciate it another 1,740 hours, which is exactly what we did. We did not depreciate it the full 4,000, okay? So 1,740 times 23, 40,020, and we're done. We're done with depreciation. We may use it another year, 2 years, whatever, but we're done. We can't depreciate it anymore. Keep in mind, depreciation is only an estimate. We're estimating as best we can. All right, so that's units of production. Let's move on to our third method called the declining balance method. This method, again, we're going to use the same numbers, 550,000, 5-year life, $50,000 salvage value, and back to estimating that it'll last for 5 years. All right, the easiest way to figure declining balance method of depreciation is set up a table similar to what I have here. You want to have year, and we're going to fill out the rest here, but you want to have a heading for year. You want to have a heading for book value, sometimes called carrying value. Book value, carrying value is the cost of the asset minus any accumulated depreciation. Make sure you make note of that because you're going to need that. Book value is the cost of the asset minus any depreciation we've already taken on the asset. Well, you can see in year one, we haven't depreciated the asset yet. So it's just simply the cost of the asset, 550,000 minus 0, because we haven't depreciated it yet. We're going to multiply that book value times a rate. And the rate is very simple. We're going to make this so simple. The rate is always 2 over the life of the asset.